This video describes how to create graphs for quantitative data. So we've already looked at how we determine how to summarize data, right? It depends on what kind of variables you have, categorical, quantitative. And so with quantitative data, we looked at numerically summarizing one variable via measures of center and spread, and with two variables, covariance and correlation. And then above and beyond that, we then talked about doing those summary measures for subgroups of data. And so when we start thinking about doing graphs instead, well, we can do the same kind of things, right? We can do graphs that will let us look at center and spread. We can do graphs that are going to let us look at the linear relationship between two variables. And then we can also do those kinds of things for subgroupings. And so we're going to stick with the ggplot2 package. And so if you remember this package, it's part of the tidyverse. Unfortunately, it doesn't have the exact same syntax, right? We're using plus signs instead of doing chaining and things. They are actually working on a new package called ggviz that will eventually replace ggplot2, do a lot of the same things, but fit the exact same framework that all the other tidyverse packages deal with. But that's for another day. So if we remember from the categorical data plot section, when we have ggplot2, how we create plots, we sort of do a base plotting object. And sometimes we set global aesthetics there. So the aesthetics are things where we're mapping variables from our data set to things about the plot. So often X and Y, for instance. So we create this base object, and then what we do is we just add different layers. So most often we add a geom layer or two geom layers that correspond to different types of graphs. Beyond that, we often add layers corresponding to titles or labels or coordinate changes. And what we're going to see here is we're going to do layers that correspond to creating multiple graphs of the same type, just across a different variable. So let's start with one variable plots. So if I have one quantitative variable, the most common plot and probably the most useful one to look at would be, say, a histogram. And so basically we would need to go to, say, the ggplot cheat sheet here, and we got one variable that's continuous. So these are the most common types of plots that you'll make. And so we're going to deal with geom histogram. And so you can see that here are some of the common aesthetics that you might use for geom histogram. And there's also this bin width of, say, 5. And so those are the important things to note about geom histogram. If we just do geom histogram without doing any changes here, we get a pretty ugly looking histogram. Gets the job done, but nothing great there. So how do we change things? Well, we need to consider those options that are given on the cheat sheet. So there's the X, Y, alpha, color fill, etc. And there's also bin width. So remember, things that, so if we're going to change one of these values and set it to something that comes from our data set, that needs to go inside an AES statement. But if we're going to just set these things to something that's fixed, so to some value that's not in our data set, we don't need to put it in an aesthetic statement. So for instance, if I want to change the color of my boxes to blue and the fill of them to red, neither of those two values that we're setting there depend on anything in the data set. So I don't need to put this in an aesthetic. I just go ahead and put those options in to the geom histogram layer. So here we're going to change a couple things, and you can see that we get a much better looking histogram. So one thing that you might notice though here about histograms is that they do have a lot of variability depending on the bin width, right? So like here, this histogram looks pretty different from that one, right? And that's just based off of changing the bin width a little bit. And so another type of graph that you'll often come across or want to use that is a slight improvement in some sense on a histogram is what's called a kernel density smoother. And so essentially the points that you would have are weighted by some weighting function. And so a basic weighting function would be a normal distribution. So here's a graph that I pulled, and sorry, I forgot to source this graph and say where I got it from. But essentially there's a point here that's given a normal distribution for its weight. There's a point about right here, a point right here. And so each one of those is given a normal distribution, and we sort of weight how high the overall smooth distribution should be based off of sort of summing those heights of the histograms that or the normal distributions that we see. So there are lots of different what are called kernels that you can use. This is a Gaussian kernel or a normal distribution kernel, but there are plenty of different ways that you can figure out how to weight the points. But essentially what this does is it gets rid of that sort of static jumping around by changing the bin width, right? This smooths it across everything. And so the appropriate layer for a kernel density smoother is geom_density. And so if we do that on our uptake variable, it doesn't look very pretty. I mean, it is a smooth version, right? It looks nice and smooth, but it's just not super pretty. So of course, we're going to want to change some options on it to improve it. And so if we look at the cheat sheet, we can see that by default, we're doing a Gaussian kernel. And then here are the common aesthetics that you might want to look at. And so again, we're going to fall into that idea of, well, with aesthetics, or with these things that I'm going to change, if they depend on a variable, they go in an AES statement. If they're not going to depend on a variable, I can put them outside of the AES statement. Okay. So some things that you might want to change here would be alpha. So alpha does the transparency of the graph. So I'm going to set that to be 0.5, and that just makes it a little bit see-through. And the reason I'm doing that is because I'm actually going to fill in based off of the treatment. And so this is going to create essentially two different kernel smoothers, right? So one for the treatment, the non-chilled group, and one for the chilled group. And so by doing the alpha 0.5, I can sort of see through and make sure that I can see both of those smooth distributions. And lastly, I'm doing adjust of 0.5. That's just to slightly adjust the where these things are located. So this is now a much better looking kernel smooth graph. And again, the nice thing about ggplot2 is that it automatically creates labels and things for us. Okay, if you go back to our bar plot discussion, we talked about the idea that you can do position arguments as well. And so those follow through to these other types of layers too. And so there are position options of dodge, jitter, fill, and stack. And so rather than having these things sort of underneath each other, what we might do is just stack them on top of each other. So I'm going to add this position equals stack. Again, this doesn't depend on something in the data set, so it does not need to go inside my AES. And so now I've just stacked them on top of one another. So this gives me a little bit better overview of the entire distribution. And I can see sort of where non-chilled and where chilled is playing a bigger role. Okay, well, you know, we saw a histogram, we saw a kernel density smoother. What if we don't want to pick between them? Maybe we want to do both. Well, that's perfectly reasonable to do in ggplot. The idea of this grammar of graphics is that we can just keep adding layers, right? And so what we can do is take our base plotting object, we can add a histogram layer, and then we can also add a density layer. So we're going to actually add that histogram on, and then we're going to throw the density on top of it. And the only thing that we really need to do to make this work in this case is change the scale that we're working on. So if you look at the density plot, right, it's between 0 and like 0.07. If we go back to the histogram, it's between 0 and 10, because this is a frequency histogram, not a relative frequency histogram or a density histogram. And so there is an option to change that in your histogram statement. So if you just change your Y to this special keyword ..density ... that tells it that I want a relative frequency or distribution histogram instead. And so I'm going to do the same fill on each of these. And now they're going to overlay on top of each other quite nicely. So you can see both the histogram as well as the kernel smoother there. Now, one thing that you might have noticed is that, you know, whenever we did our AES for our histogram and for our density, we set the fill in each one of those. And so those are sort of, if you want to think about them as local aesthetics, those are local. Since there's the same for both of our layers, we might want to just go ahead and set them as a global aesthetic. So in our base plotting part here, where we're actually calling ggplot2, rather than only specifying X here, we might also put fill, and that keeps us from having to put it in each one of our subsequent layers. And now if I want to change the variable that I'm filling by, I only need to change it once rather than twice. Okay, so let's talk about some other plots that are really useful. One is the empirical CDF. If you've dealt with CDFs at all, they are just the cumulative distribution function. So essentially, if we look at, say, the value 20, this is saying that about maybe 33% of the data is below 20. So this is just giving me a way to determine sort of where my distribution, where my values lie, just in a different different visual. So the layer for this that you're going to add is actually a stat layer, not a geom layer. Okay, so if we go here, remember these are sort of your basic plotting layers here, but sometimes you can also do things that are over here. So alternative ways to build your layers are stat layers. And so we're going to do the layer corresponding to our CDF. So stat_ECDF. And here we're actually specifying that the geom should be a step function. So again, there's this sort of oftentimes one-to-one correspondence between geoms and stats. When you call a geom, it's going to utilize some stat. When you call a stat, you can specify some geoms sometimes. So we're saying use a step function and use the ECDF as your statistic. But even if you're going to use, say, a stat layer, it's still really easy to change it up and to add your different options to it. So here we're going to go ahead and add an aesthetic for color, and we're going to color by treatment. So essentially I'm going to get two empirical CDFs, one for non-chilled and one for chilled. And then I'm also going to add a layer corresponding to the Y label, just to make it a little bit more intuitive. And so if you've ever done survival data or dealt with data like that, ECDFs are used quite a bit. Okay, so now let's move on to talking about two quantitative variables. The most common plot there would be the scatter plot. Okay? And so let's read in some data so that we can create some scatter plots. We're going to read in this data that corresponds to NFL box scores. And so it has, for every game from like 2002 to 2014 or something, it has the sort of scores for the away team, the home team, and a bunch of other stuff. And so we might want to make a scatter plot that corresponds to home rush yards and home final score. So maybe what we're interested in is if a home team can have more rushing yards, do they have a higher final score? And so the appropriate layer here would be a geom point layer. Okay. So the things that we need to specify for a geom point layer would be what's on the X and what's on the Y. So we're going to do that in our global aesthetic. Okay, so let's check out this scatter plot. This is our very basic scatter plot, gives a point for every observation with home rush yards and home final. Okay, so that's fun. We can, of course, do a lot of fun, fancy stuff with scatter plots. So one thing that you might want to do would say add in a regression line, so the line of best fit. Well, to do that, we can just add a geom smooth layer. And so again, you probably want to reference your cheat sheet to see the kinds of things that you can do here. But if you're starting to talk about two variables where you have a continuous X and continuous Y, here are some of the different layers that are common. So of course, the geom point is what we're starting with. And the other thing here that we're going to add is a geom smooth. So this is a smooth, either a smooth line or a line going through the data. Okay. So it says here that the default method is LM, but I think that's the old way. Now it's actually a GAM smoother, generalized additive model smoother. So we're going to add a geom smooth layer that's this GAM smoother, and then we're going to add just the best fit line, and we're going to color that one red. And so now we see we get two lines, and they've actually put in some sort of confidence bands as well. We might want to add some text to the plot. So, we're investigating sort of a linear relationship between these two. So perhaps I want to throw on the correlation as an actual numeric summary to the plot. That's pretty easy to do. You might have recalled that we've used this paste function here and there. So what paste and paste zero do is they just put strings together. So they coerce whatever you give it into strings and then try to put them into one longer string. And so you can determine what separates those strings by the separator argument. So here I'm going to separate it by a space. I'm just going to combine all those things into one string. So what you can do is actually use a text layer. So geom text will allow you to add text to your plot. And so in this case, I'm telling it the X and Y coordinates, size of the text that I want to add. 1 is the default. And then the label is the actual text to add itself. So I'm going to say paste together, and 0 means that there's no separator, so no white space in between or anything like that. Correlation equal, and then I'm rounding the correlation, which I've created up here as a separate R object. And so that'll throw the correlation down there in the bottom right of our graph. Okay, so what else can we do? Well, instead of plotting the actual points themselves, we can plot a label, which is kind of neat. So here we're going to just grab the Pittsburgh Steelers games. I'm from Western Pennsylvania, so of course that's who I care about. And so we're going to create a base plotting layer, again, home rush yards versus home final. And then rather than plotting a scatter plot, we're going to do a text plot, but it's going to essentially be a scatter plot where the label is the season. So here are all the different games across the seasons. So you can see there are a couple 2014 observations. And so again, you can sort of get kind of fancy with these plots. Okay, so what next? The scatter plot is the most widely used plot that you're going to do with multiple quantitative variables. But again, we talked about the idea that there might be a third variable that corresponds to some categories. And maybe we want to get each one of our plots for those categories. And that's really easy to get in ggplot. We just do a facet grid or a facet wrap. So if you go to the cheat sheet, there's a section over here on faceting. And so this divides a plot into subplots based on the values of one or more. And again, they call them discrete variables, but categorical variables. So we can do facet grid. And then they're using the formula notation that we just mentioned before. So if you put a dot that's saying I don't want any, I just want one row, and then my column should correspond to this FL variable. If I do year tilde dot, that means that I don't want, or I just want one column and I want my rows to correspond to year. You can do year tilde FL, and so that's going to actually do both rows and columns. And then facet wrap is just going to sort of figure out how many things to put based off of your output size for your window. So go and look at that. So I might just do this geom point. So I'm just going to do a scatter plot. And now I want to wrap based off of surface. So however many levels of surface there are, I want a different scatter plot for each one. And I'm going to let ggplot figure out how many should go where. And so now it's just creating this facet wrap. So it's just putting the plots one after another. And now we have a scatter plot of these things based off of this, all of these categories. So that's cool, but it gets even cooler, right? So let's go ahead and do a facet grid. So this will be a little bit more specific for us. So every roof combination versus every surface combination. So we can look at that there. And what's kind of nice is that you can actually change every one of these plots by just changing what you put into the geom point. So for instance, if I want to color each one of mine by, say, the home spread, so this is a measure of what Vegas says that the home team should win by, and you can change the size, you can change the positions and all these other things, and get them to change for every one of those graphs, which is pretty cool. I do want to go back here. I did gloss over something. So sometimes you have a quantitative variable that you want to use as a categorical variable. So there's this really nice cut function that you can do to create categorical variables from quantitative variables. So if you ever need to do that, check out that function. It'll easily split up your quantitative variable into groups. Anyway, hopefully you're seeing how cool and how useful this ggplot package is. It does all of this sort of background stuff for us, and we can really generate a lot of plots that are sort of publication ready very easily. And then beyond ggplot, there are extensions, of course. People write their own packages that sort of build on what ggplot2 has. And then there's also some packages that are just off by themselves. So one package that's kind of off by itself that I really like is the CorePlot package. So you'll need to install that if you haven't already installed it. But essentially what you can do here is if you have a matrix of correlations, so here I'm creating the correlation between these variables here. Let's go in and check that out. Make sure that I read in. I need to read in. I need to find my data set, scores. Read this in. That's not working. I'm having trouble connecting to the internet today, so I'll just go ahead and make this local. Already in my other, sorry about that. There we go. So we read in the scores full. Great, we got that. And now what we're going to do is read in this CorePlot package. We're going to pull CorePlot. And so again, the idea here is that we have a correlation matrix. So this gives us all the different correlations between these variables of interest. And so if we have that information, we can use this CorePlot function to create a nice visual of it. Okay. So again, the prerequisites for using this package, I need a correlation matrix. And now I can create these kinds of nice visuals. So the size of these circles represents how big the correlation is. So it's a visual of the correlation. And then whether it's blue or reddish determines whether it's positive or negative. And then on the flip side, since this is of course a symmetric matrix, the other side gives us the actual numeric value of the correlation. So a very nice visual if you have multiple variables you want to look at. And so I recreated this from a paper that was in Nature. So just to show you the way that you might use this, if you have a ton of different variables and you just want to provide people a visual of how they're related, this kind of plot can be really, really useful. Okay, so that's one package that I just want to show you because I really like what it does. There's another package called Gigi Ally that somebody wrote that sort of works with ggplot. And so there's a Gigi pears function, and this allows for an easy creation of graphs for both quantitative and categorical data. And so as long as you've installed that package and you read it in, you can then use Gigi pears on a data set, and it's going to produce a bunch of sort of standard graphs that you might want to see. And it keeps that same kind of notation where you have the AES statement, so you can change things as you like within the data. So this is these are auto-created graphs from the iris data set. And so again, this is a really great way to summarize that data, to look at it and inspect it. We get all the different kernel smooth densities across the diagonals, and then a bar plot down here in the bottom right for the categorical variable. So these are the univariate graphs. And then here we have all of the scatter plots or corresponding faceted histograms. And then up here we have all the numeric stuff, since again, this would be sort of symmetric if we did it. And over here we got side-by-side box plots. So, this is a really great function that does a lot of really nice things for you. And it's Gigi pears because there is a pears function as well. So if you just do pairs of iris, it will do basic plots for you. But they're just not very pretty, right? Whereas if you do this other one, things are going to be a lot nicer. So again, this is one of the super, okay. It's not as nice because we don't have the aesthetics, but this is one of the great things about R is just with a few lines of code, you can do some really neat things. Okay. So we saw these side-by-side box plots over here. That's another really common type of graph that you want to look at. And so let's show how to make those. Again, it's all about the appropriate layer. And so in this case, we're going to have our X variable be the surface. So this is a categorical variable. And the Y layer is going to be the home pass yard. So this is a quantitative variable. And I'm just going to set up my base plotting object and add the box plot layer. And I'm going to fill it with gray. That gives me this set of side-by-side box plots. You can get really fancy with this. So in some of the journal articles I read here and there, they do things like connecting lines between the groups so you can see how the means differ or maybe the medians differ. And so it takes a little while to figure all of the notation for this out, but essentially I can take my box plot layer and then on top of that add a stat summary layer where the function that I want to do is the mean. I want to do a geom of a line to connect the means. I want my line width to be a little bit bigger than normal, and then I'm adding an aesthetic for these different groupings. And so you can see that as long as there are these different types of roofs here, we get a mean for each one of them, and then we have a geom line that connects those across each one of our box plots. So this is really just to give you a taste of some of the stuff you can do, and just the idea that we're dealing with layers. So we put a box plot layer, and then on top of that, we put the stat layer. If I put the stat layer first and the box plot layer on top, it's going to look a little bit different. So it's all about layering. Let's talk about line plots. So a lot of times you end up with data that has some time variable to it. And so we're going to deal with this same scores data set, but let's go ahead and create some time data. So within here, if you noticed, we go back to the actual data set itself. 1 second. So far away. Oh, there it was. So we have this date variable and we have a season variable. So if we combine those two, we can create a new variable that represents an entire date. Okay, so I'm going to paste together the date with the season. I'm going to separate it with a dash. And so you can see that this is what one particular date would then end up looking like. Okay, and so I've done this now for the entire data set. So remember, we looked at the tidyr package, and within there were some functions for splitting columns up or combining columns. So the one for combining columns that we didn't do any examples for was unite. And so unite is going to go ahead and put two columns into one. And so here I'm saying, let's create a new column called date with a capital D, where the separator is a dash. And what I want to do is combine date and season. And I don't want to remove the variables date and season from my subsequent data set. So I got my new variable date. I'm keeping my old ones. And then I've just done over here a selective date so that it would come first and then everything else after. All right, so, at some point in time, we need to talk about dates. So this seems like a pretty appropriate time. There's a LubraDate package, which is great for working with dates. The reason that we want to switch these this kind of variable to an actual date variable is that you should be able to subtract dates, right? You should be able to take today and subtract 2 days from now and know that the difference is 2, right? And so by switching these things to actually be read in as and treated as date variables allows us to have a lot more functionality. So the LubraDate package is great for working with dates. And the dates are actually stored as numeric values that are the number of days since January 1st, 1970. Which is the same thing that SAS does if you are familiar with that. And so there's a function as.date out there within that package that will convert something to a date. It just has to be in the appropriate format. So remember, we just created this one date value that is 5-sep-2002. So if I one date that and I say that this is the format that it's in, it will go ahead and convert that to a date variable. And now what I can do is take that date and I can say add 1 to it. If I add 1 to it, I get the next day. So we now have all the functionality that you might want to deal with dates. There are functions to then go and grab, well, what day of the week was this? What day of the week was that? What month? All that kind of stuff. All right, so let's create a full date variable here. So the first thing I'm doing is I'm adding this date variable to my overall data set. And then I'm going to overwrite that date variable with an as.date version of it. And I'm just saying that this is the format for that date. So if we did that, let's just go in here, it's full. So we're creating our variable here. And now we're overwriting that date column. Now if we look at scores full, you can see that, so where did date go? Oh, date's the second one. So date is now actually stored as a date column. So that's exactly what we want. Now we're going to be able to treat it as a date, and ggplot will know when it has a date, it has to do different things. All right, so what we might want to do is, let's say, summarize the total yards for just AFC North teams for home games for each year. So there are 4 teams in the AFC North, and what we want to do is get the total yards for their home games across each year. So we have time data here, right? So we can go across years. So what we got to do first is create some summaries. So I'm going to take that full data set. I'm going to grab just the teams in the AFC North. And here's this %in% infix operator that we mentioned previously. This is great for looking at whether or not something is in a vector or a list. So we're saying for filter just where the home team is one of these 4 values. And then from there, we're going to group by season and home team, and we're going to do a summary to get the home average yards. Cool. So this is what the resulting data set looks like. So for every season and for every team in the AFC North, we have their average home yards across their home games. Okay, so now if we want to do a line plot across these year variables, we just do geom_line. Okay. So X is my season, Y is my home average yards. I'm going to color by home team. So there you go, line plot corresponding to each one of the team's average home yards. All right, so hopefully you've got a really good flavor of how to do graphs in R, right? So there's base R plotting, which is good, it's fine, but you have to do everything manually. ggplot2 is kind of the standard way right now, and it does a lot of the legwork for you. And so again, you'd want to refer to this cheat sheet in order to see sort of all the different things that you might think about doing. But hopefully you now have the tools to at least go out there and explore what you want to do. So just to give you a recap of the ggplot syntax, so you have your base plotting object, you give it the tibble that you want, and then you add your geom layers or your stat layers, and usually you're going to put aesthetic mappings within those. On top of that, we often might want to change the coordinate system, so we might want to flip them or change to polar or something. You can do facet functions, which then create multiple graphs, or maybe you're just going to change your layer.